All right, so in this video, we're going to be covering synthetic division. Synthetic division is going to be a process that we use to divide polynomials by a binomial. So I know we know how to divide numbers, right? Like a divided by 4 is 2. But we're going to be doing now with polynomials. So this is what your examples are going to look like, right? So you're going to be given a polynomial, like this one, divided by a binomial. So binomial means that it has two terms. In order to solve this, we're going to have to use the process called synthetic division. So what we're going to do right now is first go over the steps needed, or pretty much the procedure for synthetic division, and then we're going to tackle some other problems. So step number one, when you have a problem like this one, what you're going to do is that you're going to list the coefficients of the numerator in order. That's something very important. So if you notice, first thing you have to check is that the exponents are in order. So we start with an x cubed, which is the highest one, and then we have x squared, and then we have an exponent of 1 here, and then we have the variable that doesn't have an x, or the term that doesn't have an x. So you have to make sure that they're in order. Once they're in order, you're going to grab just the coefficients. So the number in the front here is 1, so that's where I put the 1, and then I put the next coefficient, which is 2, then 3, then 4. So 1, 2, 3, 4. Okay, that's always going to be step number 1. Now, step number 2, you're going to set the denominator equal to 0, solve, and place that number in the box. So there's going to be a little box here, and it's going to come from here. So I'm going to grab the denominator, which is x minus 2. I'm going to set it equal to 0. Now, in order to solve this, I move the 2 to the other side, so it becomes x equals 2. And that's the number that's going to go in this little compartment. Okay, so that's what synthetic division looks like. We're going to have a little compartment here, and then we have the coefficients here. So if you notice, this step is actually not necessary. If you notice, it's just the opposite. So if we have a minus 2 here, then I'm going to have a positive 2 here. If this would have been positive, then I would have had a negative number. All right, step number 3. This is always going to be the first thing you do when you actually start the synthetic division process. You're always going to bring down the first coefficient down under the line that we have here. So this one always comes down untouched. So the 1 came down. Step 4, every time a number comes down below this line, you have to multiply times the number in the box. So 2 times 1 is 2. That's the number we're going to be placing right here. Okay, so again, look at this. The 1 came down, and then every time there's a number below the line, you're going to multiply times the number in the box. So 2 times 1, and that's the number that you write down here. Okay, now step 5, every time you write a number above the line, you're going to add it to the number that's on top of it. So 2 plus 2 gives me 4. All right, now where did this 8 came from? Again, it's the same. We're going to repeat the same process. The 4 dropped down below the line, so we multiply times 2. 2 times 4 is 8. And then after that, again, we add, remember, because it's now on top. So 8 plus 3 gives me 11. Now again, then 11 is under the line, so I multiply times 2. That gives me 22. And then lastly, again, I add. So 4 plus 22 is 26. Okay, that's always going to be the procedure. So let me just go ahead and draw a little line of what we did. This one comes down. And then you do 1 times 2. From there you go here. And then 2 plus 2, you come down here. 2 times 4, 8. 8 plus 3, 11. 2 times 11, 22. And then 22 plus 4, 26. So it's a little zigzag line that you're going to be repeating. All right, that's step number 5. Now, once you're done with this, step number 6 is going to be actually writing down your final answer. So step 6, you're going to translate your answer into this form. All right, you're going to have your quotient plus your remainder over your divisor. So in this problem, this is the answer we had previously. Your quotient is going to come from these numbers right here. Okay, and I'm going to show you how to do that in a minute. But this is where you're going to get your quotient. This right here, go ahead and make sure you label it. This is always going to be your remainder. Okay, the last number on your synthetic division is always going to be your remainder. Let me go ahead and put a Q here. This is where you're going to get the quotient or the answer. And then the divisor is simply the, let me go ahead and make a little note here. This is your denominator. So I'm just going to put D-E-N, but you could go ahead and put the whole word on your note. So this is the denominator of the original problem. So this is how you find your answer. Let me just go ahead and go back to the last slide. This was the original problem. What is the degree of the numerator? The degree, remember, is the highest exponent. Since the degree is 3, every time you do synthetic division, the degree drops by 1. So the original degree was 3. Now the degree, after I applied the synthetic division, now it's going to be 2. So what you're going to do, these numbers here are going to become coefficients. So I'm going to have an x squared. I'm going to have an x. And then I'm going to have a number. Okay? Again, why? Because the original problem had an x to the third power. Now the degree always drops by 1, so I'm going to have an x squared. And then I just go in descending order. So we have an x to the second power, we have an x to the first power, and then we have the number that doesn't have an x. Now these numbers are the ones that are going to be the coefficients. So I'm going to have a 1, a positive 4, and a positive 11. Okay, so look at this. This is my answer, x squared plus 4x plus 11. That's my quotient. And now next to the answer, I also have to include a fraction where we're going to have our remainder, which in this case was 26. 26 divided by the divisor. The x minus 2 is the divisor from the original problem. Okay, that's how we do synthetic division, okay? So again, it looks kind of lengthy, but it's not that complicated. So let's go ahead and try an example here. So here we have an example for synthetic division. They're asking us to find the quotient and remainder using synthetic division. Again, for synthetic division, remember we have to do the little box. So how do I know what number is going to go on the square? Right, so on the square, it's always the opposite of the number here. So this is, since that is a minus 8, I'm going to have a positive 8. Now next to the square or next to the box, I have the coefficients. So before we do anything, you have to make sure that they're in order. I have an x squared, and then an x, and then the number without an x. So they're already in order and there's no term missing. So now the coefficients are going to be 1, -9, and 12. Right, so this is how I got those numbers. So again, the 8, the 1, the -9, and the 12. Now the answers are here, but just follow along, right? So step 1, we drop this one down. And then 8 times 1 gives me the 8. And then remember, you always, I'm going to go ahead and put a plus sign here so you don't forget, we always add these. So -9 plus 8 gives me -1. And then remember, since the number is below the line, I'm going to multiply times 8. So 8 times -1 gives me -8, and then I add these. So 12 plus a -8 gives me a 4. So I'm going to go ahead and put a little r here so I remember this is my remainder. And then these two numbers are going to be the new coefficients of the answer. So we finished synthetic division, but now we just have to write our answer. So again, the degree of the original problem was 2. So now the new degree is going to be 1. So I'm going to start with x to the first power. The next term is not going to have an x, so this one's just going to be a number. And I fill it in with these two here. So I'm going to have 1x minus 1. Okay? Now, when you have a 1 on the top, you don't need to write it. When you have a 1 on the front, you don't need to write it. So my final answer is going to be x minus 1 as the quotient. And then remember, you always have to have plus a fraction. Your remainder goes on top. My remainder here was 4. And on the bottom, you had the original divisor, which in this case was the number on the everything on the bottom, which is x minus 8. Okay, so that is my final answer. All right. Let's go ahead and try one more here again. So on this one, use the synthetic division again. So first thing again, make sure everything is in order. I have an x to the third power. This one has an exponent of 1. And then I have the number that doesn't have an x. Now, I know this is in order, but there's something I don't like about this problem. If you notice, they are in order, but there's an x squared missing. Okay, so the coefficient of this one is 1. There is no x squared. This one goes from a 3 to a 1. So that means that in the middle, there's an x squared missing. So technically it's there, but it has a coefficient of 0. This is very important because when you write down the coefficients, you have to make up for every single x. So again, the 1 comes from the x to the third power. So let me go ahead and erase this. This one comes from the x to the third power. Now, if you drop the exponent down, this is supposed to be the number in front of the x squared. But since this problem doesn't have an x squared, that's why I'm putting a 0. It's kind of like a placeholder. Now, the next number is supposed to be the number in front of the x, which in this case was negative 23. And then the last number, I'm going to put a c because we call that number the constant. It's the one that doesn't have an x. Now, from here, in the box, I put the number that is the opposite of positive 4, which is negative 4. And then I'm ready to do synthetic division. So I bring this one down. 1 times negative 4 is negative 4. I add 0 plus negative 4 gives me negative 4. Negative 4 times negative 4 gives me the positive 16. 16 plus a negative 23 gives me a negative 7. Negative 4 times negative 7 gives me a positive 28. And then negative 34 plus 28 gives me the negative 6. Again, this one is my remainder. And these three numbers are going to be my new coefficients. So the degree here was 3, meaning that my answer is going to start with a degree 1 less than that. So it's going to start with an x squared. Now we drop the exponent again. It's going to be have x. And then the very last number is going to be your constant, which is a number by itself. So I fill those in with these numbers here. So I'm going to have 1x squared minus 4x, again because it's negative, minus 7. Okay, so that's my quotient. Now again, every time we have a remainder, we have to put a plus and then in a fraction. Now make a note of this. Since my remainder is negative, I don't need the plus here. I'm just going to put a minus. Okay, so I'm going to put minus. Your remainder always goes on the top. Minus 6. Again, the negative, I dropped it down here. And then on the bottom, you always have the original denominator. Okay, I'm hoping you're getting the hang of this. It's not that complicated, but it could get a little tricky. So just the reason I included this problem in here is just so you can know that when there's an x missing, like the x squared, you have to fill it in with a 0. If not, you are going to get the incorrect answer. All right, so the next one. This one looks a little bit different. Use synthetic division to divide p of x, which is all this here, by x equals 1 over 7. Now, when they give you the problem like this, then that's the number that goes straight into the box. Okay, so again, I'm going to show all my work here, but this is what happened. If you don't have a problem, let me just go back to the last one. You know how here you had a whole division and you had to convert this number to the opposite. But if they give it to you like this, x equals something, then that's the number that goes straight to the box. You don't have to change the sign. Now, I list the coefficients. We have 7x to the third power. Then after that, I'm supposed to have x squared, which is 13. After that, I'm supposed to have the term that has an x, which is negative 23. And then the number that doesn't have an x, which is 3. So they were already in order and there was no x missing. They all had descending exponents. Okay, if this is a fraction, okay, don't let it freak you out. You could use your calculator. So 7 comes down, and then in your calculator, if you're going to multiply 7 times 1 over 7, you have to make sure you do this. 7 times, and the fraction has to be in a parentheses. Okay, that's what you're doing. You're multiplying. Now, 7 times 1 over 7 gives you 1. So that's what I put there. And then we do 13 plus 1, remember, so we're adding here, gives me 14. And then again, if you need a calculator, you could do that. 14 times 1 over 7. But I'm going to give you a little trick. When you have a 1 over a number and you multiply it times the whole number, what we're doing pretty much is just dividing. What is 14 divided by 7? That's how I got the 2. Negative 23 plus 2 gives me negative 21. And again, when I multiply negative 21 by 1 over 7, it's like if I was dividing. So negative 21 divided by 7, that's how I got the negative 3. And then 3 plus negative 3 is 0. So again, this is my remainder. And this is my, oh my goodness, all the way to here, sorry. That's my quotient. Again, my degree here, my highest exponent was 3, so now it's going to come down, it's going to drop. Remember, after a synthetic division, the degree drops. So I'm going to start with x to the second, and then 1 less is x. And then after that, we're supposed to have the number that doesn't have an x. And then I fill the coefficients with these numbers. So I'm going to have 7 plus, since it's a positive, 14. And then a minus 21. Okay. Now, I know after this, I'm supposed to have a fraction, right? Plus the remainder over what I divided by. But since our remainder is 0, you don't have to add the fraction at the very end. Your final answer would just be this right here. Okay, so again, make sure you write that on your notes. When you don't have a remainder, you don't have to come up with a fraction, like 0 over something. There's no need for that. So again, if you have a remainder of 0, that's actually very nice and pretty. This would be your final answer. All right, so let's go ahead and talk about something else here. So if you notice, the synthetic division helped us find, or actually divide and find the remainder and all that good stuff. But if you are just interested in finding the remainder of a polynomial being divided, of course, you can only use this when you're just interested in the remainder. You don't care about anything else. So this is what you're going to do. If you want to use the remainder theorem, step 1, you're going to set the binomial equal to 0 and solve. Go ahead and put this on your notes. By binomial, I mean the denominator, right? So again, I'm just going to put DEN because it's really hard to write here, but the denominator. So you're going to set the denominator, which is a binomial, equal to 0 and solve. And then you're just going to substitute that number that you get from step 1 into the original polynomial. And that is super awesome because once you do that, you actually get just the remainder. So let's go ahead and try this one here. So if you notice, the instructions just care about the remainder. If you want to have fun and you want to do all the synthetic division, you can do that. But remember, the remainder theorem exists to make your life easier. But again, you can only use it when you're specifically asked just for the remainder. So let me just go ahead and set this up, right? So if you wanted to do synthetic division, you would have to do the opposite of 2, which is -2. You would have to list all these numbers up here. So you would have 3, you would have -7, and you would have 3. Again, you don't have to do this, but I just want to show you what happens, right? So if you were to this, let me just go ahead and do this real quick, right? So the 3 drops down. 3 times -2 is -6. -6 plus -7 is -13. -13 times -2 is +26. And then 26 plus 3 is 29. So this right here is your remainder. And that's what our answer is, 29. So that wasn't that complicated, right? But again, the whole point of the remainder theorem is that we're allowed to skip all of this. I just did it for fun so you could see that we have the correct answer. So if we use the remainder theorem, we still have to do this step where we find the opposite of the number here. So the opposite of that is -2. And then look at this. What we do is that in that -2, you replace it back to the original problem. But again, we're just going to look at the numerator. So I'm going to have 3x squared, but instead of x, I'm going to put the -2. Minus 7 times, instead of x, -2 plus 3. So I substitute it. Now from here, we do order of operations. -2 squared gives me 4. -7 times -2 gives me +14. 3 times 4 gives me 12. And then 12 plus 14 plus 3 gives me 29. Isn't that crazy? So look at that. This was invented to skip that. So if you notice, we didn't have to do all of this, but we got the same remainder. So it's totally up to you. So when you have a problem like this one that asks you find the remainder, you could do the whole synthetic division if you love it because it's super fun. Or you could just use the remainder theorem. which means grab whatever's on the bottom here, substitute it back to the top part, and whatever number you get, it's the remainder. That's super cool, isn't it? Okay, let's go ahead and try this one out. Let's just go straight to the remainder theorem, right? So remainder theorem says grab the opposite of that, so positive 1, and replace a positive 1 into the excess of the numerator. So 3 times 1 squared minus 7 times 1 plus 3, I substitute. 1 squared is just 1. Negative 7 times 1 is negative 7. And then we just do order of operations again. 3 times 1 is 3. And then minus 7 plus 3, that gives me a remainder of negative 1. Okay, so look how much fun that was, right? So again, when they ask you just for the remainder, you're allowed to use the remainder theorem. Okay, the last thing we're going to talk about here is determining if something is a factor of a polynomial or not. So the way you're going to determine that is actually looking at the remainder. A factor will have a remainder of 0. So we might have to do synthetic division, or we could actually just go straight to the remainder theorem, and we're just going to stare at the remainder. If the remainder is 0, that means that it is a factor. If the remainder is anything but 0, it means it's not a factor. Okay, so again, if you don't know what factor means, it's just a number that goes evenly into something else. In this case, it's a term that goes evenly into something else. Like 4 is a factor of 8, because when I divide 8 by 4, I get a solid number with no remainder. So again, that's where this comes from. If you don't have a remainder, it is a factor. Now, something is not a factor if you do get a remainder, right? 3 is not a factor of 7, because if I divide 7 by 3, I'm going to have a remainder. So again, it's the same logic here. All right, so we're going to just try 2 examples here. Is x plus 4 a factor of the polynomial below? If you are a super fan of synthetic division, you could do synthetic division. Let me just show you how to set it up, right? You would grab the number opposite of 4, which would be negative 4. And then you would set these coefficients, right? So I would have 1, because that's the coefficient here. I would have negative 1. And then I will have negative 21. Okay, I'm not going to do the synthetic division, but you would do all this thing here and you would only care about this number, the remainder. Okay, again, I'm not doing the synthetic division because I know an easier way, right? We know the remainder theorem. So all I'm going to do is I'm going to get the opposite of positive 4, which is negative 4, and I'm going to replace it into all the x's. So I grab the opposite, negative 4, and I replace it. So I'm going to have negative 4 to the 3rd power minus negative 4 squared minus 21 times negative 4. I just replaced it. Of course, you have to make sure you're careful with your parentheses. If you're going to put this in the calculator, it has to go in parentheses. Now, negative 4 to the 3rd power gives you negative 64. Negative comes down right here. And then negative 4 squared gives you 16. Negative 21 times negative 4 gives me positive 84. Now, when I add all of these, I get 4. This is my remainder, but I honestly don't care because they're not asking me for a remainder. They're asking me, hey, is this a factor, yes or no? So we just go back to the previous slide. The previous slide says if you have 0 as a remainder, yes, it's a factor. If you get anything else besides 0, then no, it's not a factor. So since my remainder is 4, that means that x plus 4 is not a factor. Easy as that. Of course, you do have to show and compute all of this. All right, the last example is something very similar. Is x minus 7 a factor of this huge polynomial? Again, remember, synthetic division is there if you want to do it, but it might get lengthy because look at all of these coefficients. So remember, all I have to do is grab this, set it equal to 0, and obviously it's going to give me the opposite sign, which is positive 7, and I just have to replace it into all the x's. So I'm going to have, instead of x to the 4th, 7 to the 4th power minus 3 times 7 to the 3rd, minus 27 times 7 squared, minus 13 times 7 plus 42. And then just, you could put that straight in your calculator, but I did it in steps. So I did 7 to the 4th, which is 2,401, times negative 3 times 7 to the 3rd power, 343, minus 27 times 7 squared, which is 49, negative 13 times 7, negative 91, plus 42. And since there was no exponents, I went ahead and just put that straight into the calculator. And all of those huge numbers ended up just being 0.